Okay guys, today we're doing the notes for multiplying decimals. They do have some examples that talk about area at the top, but I don't want to focus on those. What I want us to do is we're going to skip and we're just going to start here. And when I get back, if I have time, I'll kind of show you what they're talking about. So multiplying decimals with an algorithm. An algorithm is just a rule. So when we multiply the decimals, we multiply the digits as usual, and we actually ignore the decimals. Okay, we're going to ignore the decimals. There is no need to line up the decimal if you're setting it up vertically. Okay, I'll kind of show what that means, but we're going to use the digits just as we would. Okay, the product will have the same number of digits. A digit is a number to the right of behind the decimal as the multiplicand and multiplier combined. Determine how many digits will be behind the decimal in the solution. Do not solve. So what we're going to do is we're going to find the decimal, and I want you to put a little arrow there, and then count up how many numbers are behind. 1. Okay, this one does not have a decimal, so there's no numbers behind it. This one has a decimal, and this one has a decimal. So if I count up how many total numbers I have behind, I have 1, 2, 3, 4 numbers. Okay, I'm going to just label 1, 2, 3, 4. Over here, I have a decimal right there. And then I have 1, 2 numbers behind. And on this last one, each set has a decimal. And then there's 1 number here and 2 numbers here, which makes a total of 3 numbers. Okay, it's very important that you count up how many digits or numbers come after the decimal in both of them. Now, I want you to notice that this sign they're using in the middle is another way to write times. We use the X, and then as we get older, we start to use the dot. So the person that made these notes decided to use the dot. So if you see the dot, it just means multiply. Okay. Okay, let's keep going. All right, we can use estimation to check for, what could we use estimation for? One way we can use estimation is to see if we are getting close to the correct answer. So we can use estimation to check for accuracy. Okay, so you may not know for sure if you're getting the right answer, so we're going to estimate sometimes for that. So these first examples, okay, are asking us to estimate the solution to show how the decimal answers are really close. So 1.9 is pretty close to the number 2. And 6, since it doesn't have a decimal, we can leave it as 6. So we're just getting rid of the decimal parts to see if we're getting close to the correct answer. 2 times 6 is 12. Okay. When I compare that to the decimal over here, well, yeah, 12 is pretty close to 11.4. Okay, now look at the next one, 0.94. Well, it's $0.94. That's almost 1 whole dollar. 5 is already a whole number, so I'm going to leave that as 5. And 1 times 5 is 5. We can also see, yep, 5 is really close to 4.7. And our last one, 5.7, $5.70. That's close to $6. I know we haven't talked about rounding this year, so we're not going to focus too much on it. And then we'll leave 11 as 11. And 6 times 11 is 66. Okay, this one's a little bit further off because we had to do a little bit more rounding, but still 66 is close to 62. Okay. All right, let's go ahead and turn the page. When we're multiplying, we want to line up the numbers and not the decimals. So notice how my decimal is here, okay? I would have a decimal behind my 3, but I don't need to line them up by decimals when I multiply. I just line up the numbers so that they, that I can easily multiply across. So we're gonna put it in here. This is what I'm gonna do. I'm gonna do 6, 8, and 3. And right now I'm gonna not focus on the decimal. So 3 times 8 is 24. 3 times 6 is 18. Add 2 more, 19, 20. Now, we had a decimal in the last one. So what I do is I count up how many numbers came after the decimal. I have 1 number after the decimal, which means when I come to my answer, my decimal would be right here, but I need to move my decimal the number of times that I have numbers behind. So I'm going to move it in 1 time, and my final answer would be 20.4. Now to show you that this makes sense, if I had rounded, 6.8 is close to 7, times by 3 is 21. Now 204 is nowhere near 21, but 20.4 is close to 21. So that's what rounding can help you do, is it can help you in case you forget to put that decimal. All right, let's do our next one. Now I put this 0 in. Do you think I need that 0 if I've dropped the decimal? Probably not. So let's do this. 7 times 5 is 35. 7 times 1 is 7, plus 3 more, 8, 9, 10. Now if I were to do the 0, I'd put a 0, 0, 0, 0. So I'm not going to focus on that. In fact, I'm going to get rid of my 0. It's not wrong to put it there, but we end up adding a lot of zeros that don't matter. Okay, I'm going to come back up here. Here's my decimal, and I have 1 number after the decimal, which means that I'm going to move my decimal 1 time for a new answer of 10.5. We can check it. 15 can stay 15. 0.7 is close to 1. 1 times 15 is 15. Now 15 is not super close to 10.5, but I'm going to circle those. 15 is closer to 10.5 than 105. So that answer definitely does make more sense. All right, I want you to try the next one on your own. Pause the video. When enough people have tried it, then you can come check your answers. All right, here we go. 1 times 5 is 5. 5 times 4 is 20. I could have put that 0 in there, which means I would have had a 0 over here. This time I come and check. Here's my decimal, and I have 1, 2 numbers behind the decimal, which means this time I'm going to move my number once, twice. So my answer instead is going to be 2.05. Okay, if you want to check the estimation, 0.4 is kind of like 0. Maybe we could round it up to 1. 1 times 5 is 5, and 5 is closer to 2.5 than 20.5 or even 205. So that answer definitely makes the most sense. Okay. I want you guys to try the next 3 examples on your own. Take a minute, try the first one, pause the video, then the next one, pause, the last one, pause, okay? Okay, see how you did. 9 times 8 is 72. Drop our 2, carry our 7. 9 times 0 is 0. Plus 7 is 7. 9 times 2 is 18. Okay, and my real answer, there was a decimal here, which means that 1 would be behind. So with the decimal here, I'm going to move it 1 time. And that is 187.2. Okay, here we go. 2 times 9 is 18. 2 times 1 is 2, plus 1 is 3. 2 times 7 is 14. Okay, don't forget that you're going to put a 0. And now we're working on this number. 2 times 9 is 18. 2 times 1 is 2, plus 1 is 3. 2 times 7 is 14. Add them up. Okay, then I come up here and I say there was a decimal here and a decimal here, which means I have 1, 2, 3 numbers after the decimal this time, which means I'm going to move my decimal 1, 2, 3 times to give me 15.818. Okay, last one. Again, I can put the 0 there if I want, but timesing by 0 won't change anything. 5 times 3 is 15. 5 times 5 is 25, plus 1 is 26. 5 times 1 is 5, plus 2 is 7. 5 times 1 is 5. Add my decimals, and I have 1, 2 numbers after the decimal, so I'm going to do my number once, twice. Okay, we're going to keep working. Apply your understanding of decimal multiplication to answer the following questions. Amber walks her golden retriever 1.87 miles after work each day. She works 5 days a week. How many miles does Amber walk her golden retriever in 1 week? All right, so we could add this for the first day and the second day and the third day and the fourth day and the fifth day, but the faster option is definitely to do 1.87 times 5. Notice how I didn't write the decimal, but I'm going to remember to put it in. 5 times 7 is 35. 5 times 8 is 40. 41, 42, 43. 5 times 1 is 5, plus 4 more is 9. Okay, put that decimal back in. I have 1, 2 numbers after the decimal, so I'm going to move my decimal once, twice. Now this one has a word answer because she is going to walk that far in miles. Okay, next one. Fuji apples are priced at $2.79 per pound. If Hayden purchases 3.45 pounds of apples, what will his price be? Round to the nearest cent. Cent is 2 decimal places. So we're going to do 179 and 3, 4, 5. This is going to be kind of a big one. We can do this. 5 times 9 is 45. 5 times 7 is 35. Plus 4 is 39. 5 times 1 is 5. Plus 3 is 8. Okay, put a 0. Next number. 4 times 9 is 36. 4 times 7 is 28. 29, 30, 31. 4 times 1 is 4, plus 3 is 7. I'm running out of space. Oh, I need to pick a different pen. Hang in there. All right, put 2 zeros this time. 3 times 9 is 27. 3 times 7 is 21, 22, 23. 3 times 1 is 3, plus 2 is 5. And then we add 5, 15, 15, 16, 17, 11, and 6. And then I see where my decimals were. So I go back to my beginning problem and I say that there was a decimal right here, right here. Whoops, which means I'd move it 1, 2, 3, 4 times. 1, 2, 3, 4. Whoa, that's not right. Is that right? Yeah, that's right. We're good. So I'd have 6.1, a 5 will round and 7 up to an $8. Big one. All right, Sydney and George solved problems shown below. Who made the mistake? What should the correct solution be? Well, we can't figure it out unless we solve it. I want half the room to solve Sydney's and half the room to solve George's. And then let's collaborate. So quickly decide who's going to do what and then pause the video. Okay, hold on just a second. Okay, I've got Sydney and George all set up. Here we go. Okay, I quickly solved Sydney's and we can see that I'm going to have a decimal right here and a decimal right here, which is going to move it once, twice, and so I got for Sydney 232.36. Did that match Sydney's? I'm not sure how Sydney got a 0 on the end there. But maybe it's because Sydney brought the decimal straight down and did not move the decimal 2 places. Let's make sure that George did it right. 9 times 8 is 72. 8, 0 plus 7, 40. Then we have a 0. This is 36. 0 plus 3 is 3, and 20. So we get 2, 13, 4, 4, and 2. And then we had a decimal right here and a decimal right here. 1, 2. So I'd move my decimal once, twice. So it appears that Sydney is incorrect. Okay, Sydney needed to move the decimal the right amount of times. All right, for your homework, there are 4 questions on the left side and there are 4 questions on the right side. And one of the questions on the left is going to match one of the answers on the right. Okay, So you have to solve all the questions, but you should be getting some answers that are the same. So if I got 10 from this one and 10 from this one, then they would match. All right, good luck, guys. Love ya.